Hello everyone, I'm Noah Lewin, and I got requested to do a Godot tutorial for my 2.5D character controller setup, kind of basically how it is. So I've made this project setup to have some template assets for you to use. Download link to that below. We're going to be making a CyberDuck today. To start our 2.5D character controller, we're going to create a new node. We're going to go for an other node, and what we're looking for is a character body 3D. I'm just going to search it up. Make it easier. We're going to add that into our scene. We're going to name him player. And inside, we're going to add a collision shape 3D. And in that, we'll make it just a capsule for now. Go ahead and save that. Go to our prefabs folder, just save it as player. From there, we got to add our 2.5D character. So we need a sprite. Let's go to animated sprite 3D and let's create a new one. We're going to need to make a new sprite frames for it up here in the top right. We're going to open that up, and now we have our animations tab window. This first animation called idle. We're going to open our art folder in our file system, and we're going to add our duck idle to it. Now that I can kind of see the scale a little bit more, I'm going to try and maybe make it something a little more sizable for the layout that we're going for in our game, and kind of size them up there and bring our, we can even lower our collision a little bit to kind of fit his frame here, the duck frame. Move our duck on up so it's about right there. Perfect. And then from here we can add our walk animation, our waddle I should say. We can throw that in there and make sure that loops and looks okay. There's his waddle. And let's go ahead and throw in all of his other animations as well. So he's going to shoot. So let's add his shoot animation. And this one is not going to loop as before. Bam, there's the shoot animation. Let's make that a little faster, around like 10 or so. Go ahead and add his hammer, his melee attack as well. Make that a lot faster. And that's pretty much it to set up the start. What we're going to need now is a camera 3D. Place this behind our character to a degree. And what we're going to want is some separation kind of between the camera and the collider itself. That way, if our camera gets backed up into a wall, it pushes forward towards our character more. So to add this separation layer, we're going to add a spring arm 3D. So we're going to add a new separation ray shape to it. And from there, we're going to set our length to 1.5, maybe 2. And then we're going to move our camera as a child to this spring arm object. We'll bring the camera down a little bit to it there, just so it's on the inside. And basically what that'll do, anything the spring arm checks for in terms of collision, it will try to avoid it. So another thing that we'd like to do because of that is let's set our the layer for our player onto their own, and we will name it. So we'll call layer 2, we'll call this player. We'll call layer 3 enemy because we're going to add some enemies at some point. And it'll just be good to know what is what. Next up, we'll create our player script. So while selecting from the player itself, let's go down to script and we'll create a new script. We'll make sure that it spawns in our scripts folder and we'll just call it player. Inside our script, I'm going to add a ready function, and inside the ready function, we're just going to add these few lines here. I'm just going to set the max FPS to my refresh rate, and then I'm going to set the mouse mode to captured so we don't see the mouse on the screen, and I'm also going to set it to full screen once we launch and test the game. Then from there, I'm going to add a physics process function, and then we will call a new function called movement, which I will create below it. And we're going to need to get the input for our movement. So we're going to have to add that. So let's go to project settings. Let's go to input map. We're going to go to move forward. We're going to go to move backward, move left, move right. And that's all we need for now. But I'll also just add, for the future, we'll add shoot. And then we'll add melee. And we will add jump. And we can go ahead and assign these as well. So move forward is W, it's forward on your controller, and so on and so forth. Go ahead and add those for your project. Now that we've got references to our actual move inputs, we can add that to our script. So to calculate our movement direction, we're going to make a new variable, which is going to be our input direction, and it is going to be a vector 2. And we're going to have our current direction, which is a vector 3. We're going to set our input direction to equal to input.getVector, and then we're going to basically need to provide our respective inputs for that. And I believe the order is, so you'll need to put your left here, and then your move underscore right here, forward, and then your backwards. And then to set our current direction, we're going to go, we'll basically want the transform.basis to be multiplied by new vector 3 that takes in our input direction. And then this variable that we get here is going to be normalized. And now anytime that our current direction is not equal to null, we know that we're moving somewhere. We can just say if current direction, and then we can set our velocity dot x to lerp towards our direction dot x. And then this can be multiplied by our speed, and that's the speed it takes to get to it. But we'll also need our velocity dot x here as well, so we know what we're coming from. And speed is not declared yet, so we'll have to define that up at the top, and we'll just say export var speed, and we'll just set it to 3.0 at the moment. If we don't have a current direction, we need to set this to 0. We'll want to do this both for the x and the z of our current direction as well, so we'll just kind of duplicate this and do it for the respective z-axis as well. And then in our physics process, we're going to type move and slide. Now we're going to actually need to test this so that we can move and it works. So let's make a new scene, a new 3D scene. Just call it our test scene, hit save. We'll throw this into our scenes folder. Inside, we'll add a CSG box, very basic. We're going to make it an 8x8, and then we will add another box so we can actually see if we're moving or not. And we'll throw it over here, and we're going to make sure both of these boxes have a collision on them. We'll add another box too, why not? And then add some different color so we know what we're looking at. And let's add our player to the scene and hit play and see what happens. Oh, we got an error. So I had an error, and that's just because I had regular lerp and not lerp float here. So just make sure you got lerp float there, and then we'll hit play again. This time that we go, we should be good and we can walk around. But our guy is not animated yet, which is not cool. We need to see his movement animation that we have. So we're going to go back to the player. We're going to add a new variable, and we're just going to say is moving, and this is going to be a bool, and this is false. And then we'll say if we have direction is moving equals true. And then we say that if not, then we don't. False. And then I'll make a another new function called animate. And inside animate, we are going to need a reference to our player sprite. So we're going to get that up here. We're going to go on ready var player sprite. And then we can call it animated sprite 3D because that's what it is. And then assign it to this. So we'll drag our player sprite from our prefab right on over into there. And now in our movement, in our animation, our animation function, we'll just type player sprite dot play idle, and then I'll play our idle, and then func process, and we'll type animation. I think it was animate. There you go. Animate, and we'll call our animate function there. And then if we are moving, and then else, this to here. And now if we hit play, if we are moving, we should get the animation to go. And if we stop, we don't have an animation playing. Okay, so what about when we want to jump? So let's add a jump function. And inside of it, we're going to call our player to jump and do the jump function. But nothing happens right now. We actually don't have a jump animation, so let's add that. See how that looks really quick. Nice, dude. Sick. So now we have our jump animation. We'll call this, but we're going to need something else. We're going to need another Boolean, and this one is going to be is in animation. And in our animation process, what we're basically going to say is if is animation return. So don't do any of this if we're currently in an animation. Don't do any of this. Now when we call jump, we will say is in animation equals true. We'll need to await some time. So we're gonna go get tree create timer, and let's just say 0.25 for this moment. We'll set is in animation equals false. And then we'll set our velocity.y to equal to 2. We'll also need some gravity because we don't have any at the moment. Let's go ahead and do that as well. Under our movement function, I'll add a gravity function. And this one will actually take our delta from above. Velocity.y equals lerp f velocity dot y to our -12, which is, I guess, our gravity. And we'll go 0.25 from there. And we'll actually just say if we're not on the floor, do this. Because if we're on the floor, we don't need to be putting that pressure down. Now we'll go back up to our physics process, make sure our gravity is being called. Throw the delta in there. Can even say minus equals -12 times delta. I like that even. I like that a little better because this is our change in time and then our gravity. And if you want, we can even do, we can make our gravity variable up here or even a constant if you prefer. And I'll just say -12.0 for now. And then we'll throw gravity right here. And now when we go to our player, we've got some information. I exported as an animation because sometimes for debugging and testing, it's good to know. Maybe something got stuck somewhere. His animation did not ever get turned to false, so that's why our animations get broken or something like that. Just for debugging, we need to call our jump function. So what we should do is we should add a reference to input, and what we need to check is if event is action pressed, jump, and then we need to check if we're on the floor. You can add that to the top if you wanted to as well. And is on floor because we need to make sure that we are on floor, and not is in animation. So if all of these things are true, then we should be able to jump. So let's add the jump function there. Let's hit play and see our results. And we're flying. I think it's because I hit minus equals instead of plus equals, and gravity is negative. So we don't need to have gravity negative up there. That doesn't make any sense. Nice. We've got kind of a weak jump, so let's add more velocity to that jump. Let's go back to the jump function, and we can even make that up here too if you wanted. This can be jump force, and we'll set it to 15 for now. And let's check that out. So we'll go back to the 2 down here, and velocity.y equals jump force. Play the scene. Oh yeah, much bigger jump for our duck there. We're gonna need to look around now. So let's add some rotation. So to add some rotation, what we're going to look first is we are going to be rotating, I believe, the y-axis here. Yeah, the y-axis first. To do that, we're going to add another variable, which is going to be our mouse sensitivity. I'm just call it mouse sense for short. And we'll set it to 0.5 right now, actually. And then from our input function, we'll check if event is input mouse motion. So if the mouse is moving, we're going to change our rotation degrees.y. We want to make sure we're working in degrees here to lerp itself to the same. And then we're going to make it the same, relevant to the event. So you go event relative dot x, because that is our left and right mouse movement. We'll make that times our mouse sensitivity. And then this is the weight at which it'll move towards that. I'll save that for now, and let's test the scene. And now we can look left and right with our duck. We're jumping super high. This is great. I'm going to lower our jump force a little bit, and I'm going to add a double jump feature. So we're going to add another bool. We'll just say on ready var can double jump. And we'll say equals true for first. We can double jump. And what we can change about this jump function here, make it a little cheaper. Let's delete this part. Let's add this here. So we can say if is on the floor and not in animation. And then we can say if not is on the floor and is not in animation. Then we can perform double jump, and we got to say and can double jump. So what we can do from our original jump function is just say if we've called our jump function, we can double jump because we have just done an initial jump, so we should be able to do an extra jump. Meaning if we've called an initial jump, we've touched the ground already, so we can reset our double jump to there. Now we'll need our double jump function, and this one is going to be a little different. He's going to jump force times 2. That's not what I wanted. He's going to do jump force times 2. Call this our double jump. And this is going to be a little bit longer of an animation. And we don't actually have a double jump animation yet. So let's go into our player. We'll go to player sprite and we'll add double jump. And then we'll go into our duck. And I have a full flipping animation for our duck. What the duck? Let's make sure that looks okay. Yeah, I think that looks good. Let's play it one more time. Perfect. Perfect flip. A little faster. And we'll add that there. Once we've performed a double jump, we want can double jump to be false. So we cannot call it multiple times. And let's hit play. Let's see our double jump. So the actual jump part did not play. I misnamed this, yeah. Boom, there's our jump. And we cannot double jump again. I'm spamming the spacebar a second time and it's not happening, so great. Next thing we might want to add is our attack animations. For the best melee hit registration, kind of out the bat, I would go for an area 3D and have your area 3D look for the mask of your enemies only. And we're going to not monitor at the start because we only want to monitor this once our attack is playing. So our area 3D needs a collision shape of its own, so we'll add that for it. We'll just add a sphere, and you got to think, so this is the front here. So if I'm doing the melee animation, which we can actually pause if we want. So let's pause the melee animation if we can get it in there. You can get to the next frame here. So our melee kind of comes out like that a little bit. So let's check our animation to make sure that or our area, so that it actually is looking for the radius there. Cylinder might even be good for this particular attack. And then you'll try to kind of just eyeball it a little bit, because this is your hitbox, right? So you don't want it too crazy, but you want it fair, because you're going to be looking left and right, so there's going to be some kind of angle cutoffs here. So a little more is better than less, I'd say, in this particular situation. We'll call this our melee hitbox. And then in our inspector, right, you see the node here. We'll go body entered, which only gets called when something in the mask it checks for goes into it. So if like an enemy walks into it, for example, we'll connect that to our player script, and then we will say body dot take damage. We don't have a script for this yet that tells us what this does, but we will soon. So we'll just put body take damage for now. We're going to need to add a function. So I'm going to copy our jump function again, and we're just going to call this melee. I think I call it hammer as the actual sprite itself. It is 6 frames, so 6 out of 15. We'll need a reference to our melee hitbox, which is our area 3D. And we can just drag that right here to get a reference to it. And then what we'll say is during the time of this animation, we'll say that the hitbox is monitoring. So if anything comes in that hitbox during this time frame, it will receive damage. And then we'll make sure to turn it off after our animation is done. We don't need any of this. And yeah, that's pretty much it. We just need to call it now. So it will do if event dot is action pressed melee. And then all we need for this one is just to make sure that we aren't in an animation. So as long as we're not in a animation, we should be fine to call this. Let's hit play again. And now we should see our melee attack. I'll go ahead and do the exact same thing for our gun animation, because we have a shoot as well. This one's going to be different. We're not going to use the area 3D for this. We're going to use a raycast instead. Shoot. Let's see, how long is the animation for the shoot? That is 5/10, so that's 0.5 for the shoot animation. We can even make that probably needs to be a little faster, but let's just keep it there for now. We're going to get rid of these hitbox markers here, and I'd say about halfway through the animation is when the bullet actually shoots. So let's just divide our time in half here. We're going to add a raycast 3D to our character, and just like the area 3D, we need to make sure that it is looking for the enemies and not anything else. This will be our shoot ray, and you can see right now our ray is just facing the ground, and it needs to face outwards. So I believe that's the Z axis, right? So it needs to go negative on the Z. So we'll go -10 for right now, and here's about the range of -10 on the pistol. Another thing that you can do here is attach this ray to the camera. So if we do end up rotating I believe on the X of the camera, the X axis, that the ray will follow, and you can shoot people who are higher up. But for now, we'll just keep it as is. Back in our shoot function, I'm getting a check for our ray. So this is our shoot raycast, and it is a raycast 3D. And it is our shoot ray right here, and we'll just check right in the middle of our time check here. We'll just do is colliding. If is colliding, then you say shoot raycast dot get underscore collider dot take damage. and it'll call that function that we have not made yet. So we still got to do that. All right, so we're going to take a similar step now to add this function that we did to make our player. We're going to go and add another node, and we're going to go character body 3D. And here is going to be enemy 1, or enemy A, I guess. You can even copy over this data from your player if you'd like. But in our player sprite, we're going to make a new one. And we're going to grab our penguin. Here's our idle. Here's our bad guy, Mr. Penguin. We'll add a new script to him as well, and we will call this basic enemy. In there. Other thing we want to do is change our layer to be the enemy layer. And we will save this prefab as enemy A. And inside our enemy script, we will add a function called take damage. And we'll need our reference to penguin sprite, or enemy sprite, I guess. If we're going to keep this more general. Animated sprite 3D equals penguin sprite. And then we will say penguin sprite dot play idle. We'll have to add a death animation. So we'll go penguin hurt. And then what we'll do from there is we'll just say await get tree create timer. We'll have it wait like not too long, just long enough that it plays the animation. And then we'll say queue free to delete the enemy. Let's go into our test scene again, and let's add our enemy A prefab. Oh yeah, one thing I forgot to add on him was to make sure his sprite is a Y billboard, so it follows. That way we can see him all the way around like that, and set his default animation to idle. And now anytime this guy takes damage, we should see that animation. Oh, we got him. That was awesome. Yeah, that is our basic 2.5D character controller for right now. We've got our basic shoot function and our melee function, and enemy working, our double jump function. So we got some different movement mechanics going on here for Cyber Duck. And yeah, I think I'll continue this tutorial project in the future and maybe add some other stuff and teach you some other techniques to make this even more fun and utilize kind of what we built on in this first episode. But for now, that'll be it. The download for this project will be in the link below for this part of the video. It'll be on GitHub. And yeah, I hope it helped.